Hello, everybody. We are here representing Yamato Gokin, a special copper alloy manufacturer. Our company is an SME with about 150 employees, and we have been making copper alloys for almost 70 years. My name is Lauren, and I work in Yamato Gokin's Quality Assurance Department. So to speak briefly about the history of our company, we were founded in 1953, and since the beginning, we've specialized in special copper alloys. We make over 100 different grades of copper alloys. Our factory headquarters are in the town of Miyoshi in Saitama Prefecture, about an hour outside of Tokyo. And we have two factories, the Miyoshi Gokin plant in Miyoshi and the Asaka factory in the town of Asaka. In terms of the types of material that we produce, we supply raw and semi-finished materials, and we can do everything from casting to machining. So every stage of the manufacturing process, we develop individual new materials for new applications, in addition to established materials according to existing specifications. And in terms of the characteristics that distinguish our company, in addition to our experience with copper alloys and our long history making them, and our start to finish production process, which means that we can customize every step of the manufacturing because it happens in-house. We also have an R&D department that is continually working to both improve the products that we already make and to find new products and new applications and invent new materials to meet our customers' needs. We also believe as a company in having well-rounded employees who know everything about everything. So there's frequent departmental rotation so that the people who are making our material and selling our material get firsthand experience in every stage of the process. We also have external lecturers come in to do study lectures at the company. To speak a little bit about the equipment that we have and our technology. In terms of melting and casting, we cast the ingots from the raw materials here at our company. We have high frequency induction furnaces, as well as gas furnace and middle frequency induction furnaces of varying sizes. So according to the scope of the order, we can use the appropriate furnace and we can customize the casting method and the chemical composition in order to meet our customers' needs. We also have both forging and extrusion equipment on site. We have one 1.5 ton forging press, 3 air hammers for open die forging. We also have a 2.7 ton extrusion press. And by cold and hot working the material, we are able to homogenize the grain structure and increase the properties of the material. Also, we have heat treatment furnaces on site. We have both gas and electrical furnaces. And by using the appropriate heat treatment on the appropriate material, we are able to control the microstructure of the material and thereby adjust the properties for the application, improving electrical conductivity or elongation or strength, depending on what it needs to be used for. And our integrated manufacturing system, where every stage of the manufacturing happens in-house, allows us to deliver materials quickly as needed because everything happens in one place. It doesn't need to be transported from one place to another. And also it allows us flexibility when it comes to adjusting the manufacturing parameters. As a company, we specialize in high mix, low volume manufacturing. So we, instead of mass producing only a few types of material, we make small quantities of many different types of material, different grades of alloys, and then also different sizes, different shapes. And one of the things that allows us to do that is the fact that we control every step in the manufacturing process. One of the fields that we are currently working in is the fusion energy sector, and particularly the ITER project, which I am sure you are familiar with. To explain a little bit more about our contributions to the ITER project, there are several different countries that are working to contribute material to the ITER reactor. And we are currently supplying material to 3 components of the diverter. First, the inner vertical target, the outer vertical target, and then also the first wall blanket. I'll talk a little bit more about those in the following slides. So in terms of the outer vertical target, this is the component that is being supplied by Japan for the project. In the outer vertical target, the cassettes, there are monoblocks that have an inlay of oxygen-free copper. Within those monoblocks, there are copper chrome zirconium tubes, and these are what is being supplied by our company. And within the tube, there is also oxygen-free copper twisted tape. So as you can see, the material that's in these outer vertical targets is contributed by a mix of large companies such as Allied Material and SMEs such as ourselves. Our history with this project started in 2006 when, thanks to an introduction from Mitsubishi Materials, we were contacted by QST, who invited us to try manufacturing these cooling tubes for the diverter. But the nature of the tubes is that because they are subjected to a very high temperature heat treatment while they're in the reactor, they need to maintain a very fine microstructure and high mechanical properties even after being subjected to this heat and pressure. And our first manufacturing trials were initially not successful, and we saw some abnormal grade growth in the material. But our R&D team worked together with our manufacturing team to fine-tune the process and adjust the parameters. And eventually we were able to make material that successfully met the requirements even after the necessary heat treatment. And in 2016, the test diverter that used our special alloy tubes was the first in the world to pass qualification trials. In the following years, we patented the manufacturing process of these tubes, both within Japan, and also we submitted patents that were approved in the United States, Russia, South Korea, China, and the EU. Starting last year, we've been supplying tubes of this for this application for the full-scale supply. So that is roughly 500 tubes for the next 5 years that we will be supplying for this project. Another area where we are supplying these cooling tubes is the inner vertical target, which is being manufactured by the EU. In the EU, there are currently 4 companies that are bidding to build these cassettes, and they have their own freedom to go with whichever raw material suppliers they would like to use. And currently, 3 of the 4 companies that are in competition for these orders are committed to procuring 100% of their material from us. Lastly, we are supplying material to the ITER first wall panel. Specifically, these panels use, there's a layer of copper chrome zirconium in the panel itself. And overall, there is 460 tons of this copper alloy that will be used in the panels that make up the blanket. And currently, roughly half of that material is planned to be sourced from the EU. And in 2019, we got a contract with the EU organization Fusion for Energy to produce a prototype plate for this application. We were able to successfully manufacture material that met the requirements, and this allowed us to be eligible for bidding for the full-scale contract. We were in 2020 qualified as a qualified supplier, and in 2021, we got our first order making these copper chrome zirconium plates for the actual application in the actual reactor. So we have been making that material last year and this year. So that's a brief history of our company and our work in the fusion energy sector. Thank you very much for listening, and please feel free to go to our website if you have any more questions. Thank you very much.
Thank you very much for a very nice presentation. The history of alloy development for ITER is very interesting to me. Thank you very much.
Thank you.
And we have 2 additional companies in the poster session in demo, Hitachi company and Metal Technology company. And the presenters of all 9 companies will be available in demo site tomorrow. So please visit the demo site for further discussion. And if you cannot visit the demo site and have a question or comment, just please send email to me, and I will try to forward your comment and question to the presenter. And I'd like to thank to all participants, all the presenters and audience. And I'd like to close this session. Thank you very much for your participation.